So I'm adding this additional video because I couldn't edit the last video. I think I had already saved it, or I don't know, whatever. And this is not something that's in the HL curriculum, but I said a bunch of things on the other solution video that are actually incorrect. And I was educated by Sokos himself, actually, on Facebook of all places. And so I have some comments on the intensity of the central maximum as a function of the slit width for single-slit diffraction. This is not addressed at all on the first page, numbers 1 through 6, so let's go to the next page, number 7. So apparently using something that I to be honest, don't remember learning in my physics classes, and I have a physics degree. I probably did learn it, I just don't remember it. Using something called phasor algebra, we can figure out how the intensity of the central peak varies with the slit width, but there's one net takeaway, which is really not that complicated. So I previously had said that the intensity of the central maximum has no relation to the slit width. That's not true. And I think I was saying in my other solution video that my gut told me that that wasn't true, but I couldn't kind of figure out why. But now, without, again, getting too deeply into the derivation, I can just say that the intensity of the central maximum increases as the square of the increase in the slit width. So, like if I were to make my single slit twice as large, that would give me 4 times 2 squared, 4 times the intensity of the primary maximum. If I were to triple the slit width, that would give me 9 times 3 squared, 9 times the intensity of my central maximum. And so this graph right here, which again is not actually in the curriculum, so I don't know why Mr. G is going there, but for what it's worth, it is not a straight line, no relationship. That would be the appropriate curve as the answer to number 7. But again, not in the curriculum. And then finally, this also applies to number 12, where it says, which pattern will have the highest intensity central maximum? My original thought is that they would all have the same intensity central maxima, and that's actually not true, because the question says that the 3 different slits are B equals lambda, B equals 3 lambda, and B equals 6 lambda. So again, we have theta equals lambda over B, so as B increases, then the angle is going to decrease. Just making sure I'm reading this properly. Label the patterns with their corresponding B values. So the largest B would be the tightest angle. So that's 6 lambda is the top one, 3 lambda is the middle one, and just straight up lambda is the bottom one. But we also said that as B increases, the intensity increases with the square of B. So it says which pattern will have the highest intensity central maximum and why. That would be the first. That would be the 6 lambda, because as the slit width increases, intensity also increases as square of B increase. So, which is not what I said in the previous video, but again, this is not actually in the HL curriculum, you don't actually need to know it, but what I said in the previous video is not correct physics, and I don't like just letting that go. So, there you go. Thank you.